For these, we want to find the measurement of each of the interior angles. And as I look at this thing, we've been finding the total of the measurements of the angles. So what do they all add up to? But now we're simply going to divide out to find the measurement of each individual angles. Each of the individual angles. And so when I look at this one, this first one is a hexagon, but it's a hexagon with some special markings on it. First of all those little dashes on each side, that means that all of those sides are the same. So this is an equilateral hexagon. But I also have little arcs at each angle. That means each of those angles are the same. So it's an equal angular hexagon, which means that this is a regular hexagon. And that's kind of what we need. If we want to find the angles individually, all right, we want to just divide to find them, they have to all divide out evenly. They all have to be the same. So this thing has to be a regular polygon. So that's what we're looking at here. What are the measurements inside a regular polygon? And most polygons we deal with are going to be regular types of polygons. We construct, when we look at like things that we construct in terms of architecture, in terms of shapes, those kind of things are designed to be regular polygons. And then we can find the angles based on those regular polygons. So if I look at this one, the first thing I want to do is find the total of the angles. If I look at this, it has 6 sides, so I'm going to do 180 times 6 minus 2. And so I can use this. I can find the measurement of all of the angles added together. Oh, and it looks like I already plugged this into my calculator, but here I go again. 180 times 4. And so that gives me 720. And so that's the total of all the angles together, all right? And so those 6 angles, there's 6 angles in here. Those 6 angles add up to 720, but each of those 6 angles must be the same. So if I want to know, well, if there's 6 angles that give me 720 altogether, what is each of those angles? I just have to divide this by 6. So I divide this by 6, and again, that's a job for my calculator, and it gives me 120. So 120 degrees, that's the measurement of each of those individual angles. So this angle is 120, this one is 120, this one is 120. And what happens if all 6 of these are 120, that adds back up to 720 degrees, okay? So the total is 720 divided by 6 means it's 120 each, okay? If I look at the next one, it says a regular heptagon. Once again, a heptagon, if you don't know what that is 7 sides. So n is going to equal 7 here. So once again, I start with the total. I say, all right, 180 times n minus 2. So 7 minus 2. Getting a little ahead of myself. 7 minus 2, which will end up being a 5 that I plug into my calculator. So here we go, 180 times 5. So all of those angles together give me 900 degrees. Okay? But now if each of those angles, because it's a regular heptagon, it means all 7 angles will be the same. So if I have 7 angles that are all the same and they give me 900, well, if I want each angle, I just divide that by 7. Once again, that's a job for my calculator. And it gives me 128.5714. So it didn't divide evenly, but let's just round it off. I'll say 128.57. And if I was actually measuring this thing, that would be accurate enough for me to actually do some hands-on stuff with a heptagon of some sort, or to construct those angle measurements if I was creating a heptagon, that kind of thing. Okay? So anytime we have a regular polygon, all the angles are the same. Well, if I know the total, I can just divide that by the number of angles, and it'll give me the measurement for each individual angle. Okay?